Good afternoon. So before we can scan this QR code to the tenants. I will wait for a minute or 2 minutes to others to join. And then we'll start. Okay, so let's start. First of all, open the virtual lab. Computer science engineering department. Different labs are there. Police processing lab. This particular lab is designed by RIT. This is the list of experiment. So we have already done some of the experiment which is listed here. Okay, like yes, mathematics and distance and connectivity, how to find the distance between the pixel and the connectivity. Similarly, we also completed the point operations on the images, how this point operation can be affected. Then we have also seen the Fourier transformation. How we can perform a Fourier transformation for an image. Now, in today's lab, basically we will perform an experiment that is called image histogram. As we know that for image enhancement, for the image enhancement technique, now this histogram plays a very vital role. Okay, so uh, basically this histogram shows how the intensity is distributed over the particular image. Okay, so histogram is we will basically calculate or we will see which is how this intensity of the picture, okay, intensity of a picture is how it is distributed. So let us begin today's experiment, which is your image histogram. So these are the main objective of this lab. There is a two main objective of this lab called image histogram. The first objective is your to understand how frequency distribution can be used to represent an image. So as I already said, okay, so histogram is how the intensity of the image are distributed. Or basically, we can say how the frequency of this intensity are distributed. That is nothing but image histogram. So we will study that. Or we understand how frequency distribution of an image to represent, we can use to represent an image. Or here the frequency distribution is nothing but intensity level of an image. Then second objective is to study the correlation between the visual quality of image with its histogram. So we will also learn, okay, the second objective is we will also learn what is the correlation between the visual quality of the images with the histogram. So these are the two main objectives that we are going to perform in this lab. Fine. Okay, so let us see the introduction part. So it's a basic introduction for what you understand by the image histogram. Okay, so it is or we can say how we can define the image histogram. Now, here the basic definition is given. The basic definition is a histogram of an image represent the distribution of pixel intensity in the image. As I already said, so what is a histogram? Histogram of the image represent it is nothing but distribution of the pixel intensities in the images. So whatever suppose this is my image. Let us understand this is my image. Now, images as we know that the images are divided into different pixels. Now, each of these pixels will have certain intensity. Okay, each of these pixels will have certain intensity level. Now, suppose the intensity level, suppose intensity level here are 10, 16, okay, like this we can have each of these pixels will have certain intensity level. Yes, intensity level depend upon if it is a grayscale, the range between in between 0 to 256. The grayscale image, the range will be 0 to 255. Fine. So what we will do now, what the histogram will represent? If I draw the histogram of this particular image, it is nothing but a frequency distribution. What will be the frequency distribution of what? The frequency distribution of this particular intensity level. Okay, now if you see, if you count, suppose the 10 is appearing 9 times. Okay, 10 is appearing 9 times. So if now I will map this intensity from 0 to 255. Okay. Then suppose this is my 10. Okay. Now suppose this is my 9. So the frequency distribution will be something like this. So the horizontal bar of what this the or because of the frequency distribution. Similarly, 12. For 12, suppose 12 is appearing 4 times. Now the frequency distribution will be something. Similarly, each and every intensity will have certain frequency distribution. Okay. So this is called the histogram representation. Now this is the we can say that this is your histogram representation of an image. This is our histogram representation. This is our original image. Okay, so our original image, and this is our histogram representation. Fine, it is clear to all of you. So the histogram of image represent the distribution of the pixels, okay, pixel intensity in the images. Now, histogram provides a statistical information about them. No, it is very, very simple. So as we can see that this is our frequency distribution. So it is nothing but it gives certain information about the image. So, and what type of information is it? It basically gives a statistical information. Okay, statistical related information. Okay, this particular basically we study the histogram of the image basically to get some certain statistical information for the image. And these are we can say that these are used in applications such as now this particular histogram representation can be used for the application such as image enhancement. So as we have learned different image enhancement techniques, okay, basically for improving the quality of the images or improving the context of the images. So it is basically very helpful, or we can say this histogram representation has major applications in image enhancement, image compression. So whenever we want to compress the image, so whenever we want to send a data in a low bandwidth, okay, जब कभी भी हम लोग low bandwidth data को send करते हैं, so we need to compress the images, okay, so that the size can be compressed. So for that also, this histogram representation plays a vital role. And the third application where we can use is segmentation. So as we know that segmentation is one of the property of we can say image processing, where basically we will differentiate the uh, objects from the background. So whatever the specific object we require to study, that can be differentiated with the background. That part is for segmentation. Again, the histogram representation has a vital role in a segmentation. For instance, we can say that for example, based on the information present in histogram, it is possible to develop a transformation function which improves the quality or the visual appearance of the images. So as we know that whenever performing the image enhancement, so what is the general formula? General formula is your g of xy. This is my output image. Okay, so what basically we are doing now, I am performing certain transformation operator, or this T represent your transformation operator. It can be a linear or non-linear operator, which basically applied to your input image. Okay, this is our basic mathematical formula. Okay, basic mathematical formula which is used for image enhancement. So this is our output image. Okay, output image, and this is our input image. Input image is given. Now this T, this is very important. This T is nothing but transformation function. Now what we have to do now, we have to choose for different images. We will going to choose the different transformation function. Now here major challenge is, one of the major challenge rises here, how to choose the proper transformation function. Okay, to improve the quality or visual appearance of the images. How we can decide whether we have to perform addition operator, subtraction, multiplication, or logarithm operator. So whatever different linear and non-linear operator we have studied. So what type of can be performed? Now what how this histogram representation is useful. Now, while studying this histogram representation, we can decide what type of transformation functions can be used here. Okay, so this is one of the example where this image histogram plays a vital role. It is possible to develop a transformation function which improves the quality as well as visual appearance of an image. Fine, I hope it is clear to all of you what you understand by image histogram. So if you want to note down something, you can note down. I will wait for 1 or 2 minutes. Okay, so let's move on. So let's see the theoretical part regarding the histogram transformation. So okay, so let's understand the theoretical part related to the histogram representation. Now, if there is a given image, one of the suppose I am saying that there is a given image. So the image is A. Then the histogram is basically represented by h of K. Now, suppose this image is given. Now, the given image is I represent this given image. Now, this is my input image. This is K. Now, histogram representation is your h of K, which can be derived by counting the number of pixels at every gray level. Okay, or if it is a grayscale image, now if it's grayscale image, the gray level will be ranges from maybe something 0, okay, something 0, 1, then 2, and get up to 255. Fine. The level of intensity will be 0 to 55. Now you have to count each and every gray level. That means how many times the zeros appear. Now suppose the zeros appears 0 time, how many times the 1 is appears, suppose 1 is appears 14 times, how many times the 2 is appear, how many times 3, 4, like that. I have to count each and every pixel uh, at the gray level. Okay, so what are the gray level of that pixel? Okay, now that level is represented by a k. Then this h of k is given by n of k. Now k is level intensity. Suppose I have to calculate, if I want to calculate h of 1. Now this is understand that I am calculating the frequency distribution for the gray level 1. So suppose it is for 40. Now it will be n of k will be 40. Now what is the n of k is representing? The n of k is representing how many times this particular level is appear in my entire image A. This is called your mathematical formula. Now the mathematical formula which can be given as you can see is h of k can equal to n of k, where k equal to 0, 1, 2, 3, k minus 1. If it is the 8-bit image, Okay, so it is 8 images. We know that total number of range will be 2 to the power of 8, which is nothing but 256 possible grayscale images. The range can be 0 to 255. Okay. Now you can see definition where n of k is the count of the pixel. Okay, each pixel you have to count the intensity of each pixel at the gray level k, and total number of bins in this histogram. Okay, total number of bins in the histogram is k. Now theoretically, the maximum value of k can be determined by the pixel depth m of the images. Okay. For instance, if I say m equal to 8 bit, if it is 8 bit image, okay, then the grayscale image we can have maximum to the power of m. That means to the power of 8, which is 256 bit. That will be equal to k bins, and for a binary image, it can be only 2. Fine. How many bins means uh, how many different types of grayscale level we can have. Sometimes the value of k is chosen to be different from to the power of m. Now this depends upon how we are choosing. This will be alter the appearance of an histogram. Now, these are some examples are given about the histogram. Some of the examples we have taken where the number of beams we can see now here is in this case the beams are very much closer to each other. On the second case, it will be little bit scattered. Now, the third case, if you see, the beams are completely scattered. Okay, three different way of representing the histogram. Okay, so here the image, here some example given. The image appearance, the table basically represents two columns here. One is your image appearance, second one is your how the histogram will be look like. Now, if the image appearance is completely dark, okay. Now, if you confine to a low gray level images. Now, if the image appearance is bright, it is confined to high gray level. And if it is a pure contrast image, the image histogram represented will be narrow. And if it is high contrast image, then the histogram representation will be wide with a good spread. In the third case, we can see, okay, in the first case, it will be a pure contrast image, okay, because the histogram representation of this frequency distribution are quite narrow or closer to each other. And this is high contrast image, the representation of high contrast image. As we can see, the wide range of frequency distribution. Fine. And this property of histogram is used in a context-specific retrieval application for roughly category images. Other uses of the image histogram are also there. Uh, that can be, we can say, the qualitative description of the image by pixel statistical information. So we can find the mean value of the intensity. Similarly, we can find the median value, and we can find the like standard deviation and number of modes of the images. So these are some other applications of this. Apart from the two major applications that we have already discussed, that is image enhancement and image compression and image segmentation. Apart from that, you can find the mean of the images or intensity, mean intensity, or we can sometimes you can find the mode of the images also, and like you can find the standard deviations, and uh, you can go for also the number of modes that is present. And this information in turns are useful for processing of a given image to enhance or analyze the content of the image which is described in detail. In the next section, we will detail that we are processing. Now we'll see how this can be useful. Fine. Now, next paragraph that is given something about, as we have already said, I have already said, the objective of this particular experiment. That two objective. One is your how we will study the histogram representation. Second objective is processing. Now, how we can process this histogram to get some of the result. The context of these images can be modified by manipulating the histogram. Okay, now histogram processing is we have to perform certain operation. Now we will perform certain operation on this histogram to get certain result on this. A popular method is called histogram equalization. Now one of the method is histogram equalization. So if you want to make a certain enhancement, so we will go for the histogram equalization. And the given histogram is manipulated such as distribution of the pixel value in evenly spread over the range 0 to k minus 1. And we know that histogram equalization was one of the main method that we are using. So the histogram equalization can be done at the global level as well as a local level. So there is two way of histogram equalization method. Either you can perform in a global level, then we have to compare the entire neighborhood pixels. Okay. If you're comparing the local level, so we consider only uh, the pixel that is having the connectivity with the particular pixel. Fine. So in the case of global level, the histogram of the entire image is processed, whereas the local level, the given image is subdivided and the histogram of the sub image is manipulated individually. So when the histogram equalization applied locally, the procedure is called adaptive histogram equalization. So this method, so whenever you go for the uh, local equalization, local histogram equalization, that method is called adaptive histogram equalization. So let us understand the procedure part, how this different procedure, that is, what are different steps that we will going to perform in this example. Okay, so there is a two method we are going to perform. Okay, in this experiment, there are two methods. Okay, one is your histogram representation, second one is histogram processing. So the experiment is designed to understand and learn the image histogram concept, first of all. So the main objective of this experiment is to understand and learn the image histogram concept. Why we need an image histogram, what is its significance, and how we can convert an image to its histogram format. Now, to perform the first experiment, that is to visualize or to convert the given image into histogram, the very first step is you have to select the image from the given image by the select image option. Then, once we selected the image, that image will be appear in your input window. Then select the region of image to load it in input image panel. So whatever the image option we are having, so generally as we already seen, there is a 9 images are there. So out of 9 images, you have to select a region of image for which we want to perform a histogram equalization, or we want to derive an histogram representation. So once you have selected the region, now select the option from full image histogram. So as I have said, there are two types of histogram representation. One is your local level, which will be select the full image. Second one is local, so global level, which will select your entire image. Then your local level, which will be select your sub images. So we will select the full image and divide histogram. Then we select the run option to perform this operation. So when you click on the run option, then you can see the particular output. So the output of the result will be displayed in the output tag. So where the output you can see. Now let me show you. Let us go to the experiment part. So first we will perform the first part, then we'll perform the processing part. Now if you're converting the image into histogram, very simple. So first of all, I have to click on this button called select image. Now as you can Just click on this button. Now there you can see you can have different types of images here. Different type of different intensity level. So you can move your mouse here over this image to select a particular image from it. For suppose I have selected this image. Fine. Now we can see this in my input panel. This is my input panel. You can clearly see that this is my input panel. This is called the input panel, and the size of the input panel here is 300 cross 300. And this is my output panel. This is my output panel on the right hand side. You can see this is our output panel. Okay, so once you selected these images, this is my images. Okay, then what we will do now, we'll simply click on the run button. So as you click on the run button, yes, now you can see, now you can clearly see here. Okay, now this is in my output panel. This is my histogram representation. As this is my grayscale image, here look at grayscale image here. So what is my maximum gray level intensity? It will be 0 to 255. Fine. And we can calculate also, there is a minimum is 0. Okay, minimum grayscale level is 0, maximum 255. And we calculate the average frequency distribution. The average frequency distribution is 153. Okay, average frequency distribution is 153. So this is how we are converting. Okay, how we are calculating this particular, let's say this histogram representation. Now you can see here clearly, this is my input image. Okay, this is my input image. This is my input image, and so this is our histogram representation of this image. Okay, now you can select different images here. Now let me take one more example. Now suppose I select this image of this tiger. Okay. Now once you select the images, you can see that the image is uploaded. The image is uploaded in the input panel. Okay, the image uploaded input panel. Now as you click on this run button, now you can see for this image the histogram representation are changes. Now you can see here particular range from 0 to somewhere around here. You can see the frequency distribution is high here. Okay, from the 0 scale level, intensity level for 0 say later, somehow here we can say that this is 100, 0 to 150. I can say 50, 100, 150, 200. No, this will be something less than 50, so 30 or something. Okay, now you can see 0 to 30, the frequency distribution is very high. Then there will be slight degradation. Then again there will be frequency distribution. Then again, now you can see here what is the average here. Now the average is now a little bit changed for this one. Now the minimum and maximum is same. In the previous case, the average is 153, but in this case, the average frequency distribution is 130. Okay, so you can try for the each and every one. Okay, you can try for each one. So just copy the procedure first, then we will see the other things also. So because you have to write down in the lab, no? It's the steps. So just write down the step experiment, name of the experiment, then these are the steps for performing the first experiment. Okay, these are the steps for performing the first experiment. That is how we can convert an image. Okay, how we can convert a given image A to its histogram representation. Its histogram representation. Okay, of frequency distributions. Write down this one.